luxury heating and cooling, and in this video I'm going to show you how to put together an underfloor heating manifold. So first thing we're going to start with is this. This is our manifold stand. It's a metal bracket. This is kind of a temporary support that we use to hold the manifold in place while we're pouring the slab. So what we do, this gets fixed down onto our steel mesh. Manifold gets bolted on here. Then we run all the pipe work, tighten the steel, we fill it with water, pressure test it, and then we leave this in place to hold the manifold while all of the concrete floor slab gets poured. So once that's concrete's cured, we start building the rest of the house, put the roof on, build the walls. Either we can build a cupboard around this so the manifold is hidden out of the way, or chop this off with a grinder, take the manifold off here, and then we fix it back to whatever wall we build behind it. Start putting together the manifold. I'm going to use a Uponor manifold, and what I like about these is that they are a modular thing. So instead of having to buy a manifold that's like 5 ports or 6 ports or whatever, these just come as a whole lot of individual bits. So you buy all the bits and keep them in stock, and then you can make whatever size manifold you want. So for the job I'm doing tomorrow, I need an 11 port manifold. So I'm going to have 11 of these. These bits make up the return header. So this thing is an isolating valve. You can screw this down to shut off the flow of water, and then you can open it back up to let water flow through. So in there's just a little pin, and when we screw that one down, it pushes the pin in, which closes the valve. So if you have a look, you can see this little valve. When I push it down, it closes the little, pushes the little plunger down, and the O-ring seals off the port at the bottom there. These are a flow meter, right? So this is the flow header. Hot water comes in here. It's a similar sort of arrangement. Hot water comes through the body of the header, and then it goes down and out the port in the bottom. Now this, if I screw this all the way down, this acts the exact same way. It shuts off the little plunger. So this is an isolating valve too. When I wind it up, it opens up the port so that water can get down into the manifold. So I can isolate both headers using those. When this is flowing, the yellow thing here is a flow meter, and it tells me how many how many liters per minute of water is flowing through each loop. So what we ideally want is the same flow rate through all the circuits on the manifold. So we can read that off here. So to assemble this, what we do is just screw these things together. They come with an O-ring fitted already, so you don't need to go crazy with thread tape or any kind of gaskets or whatever. They all just screw together. It's pretty easy. Now we've got 2 headers. So that's the main part of the manifold. Flow normally goes on top, return normally goes on the bottom. Now I'm going to stick them on here with some brackets. So, brackets. Now they go up a certain way. I've got an arrow on there that says this way up, says top. So I'm just going to bolt those right onto there. Now I've got my 2 headers, flow and return. I'm going to fix these onto the bracket on the manifold. And I'm going to arrange them so that I've got the connection to the boiler is going to be on the left. So we're going to go around this way. These are your connection to the boiler, right? So that's an inch threaded fitting, and then the other end just screws onto the boiler on this end. Now, these 2 things look pretty similar, but they in fact are different. So one of them's got this extra plug on top here. This is the flow connector. This goes on the flow header. This one goes on the return. I use this thing to fit a pressure gauge to the manifold. I'll do that later on. So bear in mind these look nearly exactly the same, but they do have a difference. So the other thing that you've got to be aware of is these have got this little slider here. When you screw it on, this slides across and it locks into the same little rail on the manifold port. That's helpful because then when you're screwing your pipe connection in here, this thing doesn't just twist out of place. Air vent valves. These are the little valve arrangements which go on the end of the header, like, I'll put it on that one. So, okay. One of these goes on the bottom, one of them goes on the top. They've got two valves on them. This one at the top can be used as an air vent valve. So what we do, unscrew that, and you can use this to vent air out of the top of the manifold. This one is your drain valve. So what you do, unscrew the drain cap on the bottom, and then you can undo the drain valve, and that's your drain or fill point. So later on I'll put a hose connection on here, and then we can fill the manifold with water using that connector there. Actually, we'll use that one. Bypass assembly. Okay, what this does, that goes in there, and this is more important if you've got zone control on your underfloor heating system. So if you were going to have the individual floor loops individually controlled, you take these off and you would screw an actuator on there. And what it does, it's just an electric version of this. So instead of having to manually close the valve by screwing the knob down, the actuator's got an electric motor which pushes down on the pin, closes off the valve, and then opens it up when you want hot water into that one zone. When you do that, the flow through here changes. So having a bypass means that, say if only one circuit opens up, only a small amount of water is getting through, excess pressure can be relieved by flowing through the bypass and back to the boiler. I recommend using this because most pumps that come on gas boilers or any hydronic system normally are a fixed speed, not normally a variable speed pressure dependent motor. So I always put this in. This little tool, what it is, it's a little wedge shaped thingy, and what we do, shove that in there, and you can see where this is going. Pops the valve out. So now I'm going to have to take it off first, but when I screw that into there, I screw the bottom in first, and then under there the top has a collar which spins, so put that on there. Okay, ball valves. If you're not sure about a ball valve, very straightforward. It's a type of shut-off valve, just the thingy, and then closes off with the ball. Open it up, now it's open. We want to be able to isolate manifold from the rest of the system if we need to do any kind of maintenance. So this is important. Now what we do, pull that around there. We use these little gaskets. Put that in there. Then screw this onto here. Done. Now we didn't need any tools to put all of the rest of the manifold together, but for these we're going to need a spanner. Yeah. So we're more or less ready to go now. The last thing, little bit of hose pipe. What we do with this goes on the top here. This is super important because when we fill this thing up with water, any air which is in the system has to get out. So with my air vent valve here, the air is going to come out the top, but it'll squirt water out while there's water in the system. So this just lets me direct water which is squirting out here into a bucket rather than having it spray all over me. Thermometers. These are just a contact thermometer. What they do is they measure the flow of water through the flow and return ports. So they just fit into there like that. So once you've commissioned the system, you can see what your flow temperature is and what your return temperature is. When we install these manifolds, what happens is we leave it on site while the rest of the house gets built. And we don't actually need the thermometers until we hook up the whole system, which is normally at the end of the job. And that might be 6 months. I find these tend to go walkabout before then. So normally I don't put the thermometers on until we actually come to commission the system. I just keep them in the box. So when we install this, obviously we're just going to fill it with cold water. We're not going to heat it at all until we install the boiler later on. So we'll leave those for later. I recommend putting a pressure gauge on, and here's why. When we install all of our pipe work in the floor, then this is all going to stay on site. In the meantime, someone could drill a hole in the concrete slab, puncture one of our pipes, and then we don't know about it until we come to the end of the job to commission it. So normally what we do, install this, put the pipework in, fill it with water, charge it up, put a pressure gauge on so we can see that it's under pressure. Then what happens if anyone punctures a pipe, the pressure gauge will go back to 0, which is what it's reading now. So that way when we come back to site to commission it, we can say, hey, the gauge is 0, you've damaged something. Also it means we can tell the builder, keep an eye on the gauge, and if it goes back to 0, someone's cut through a pipe. Go, good enough. Okay, so there's the whole finished manifold. What I'll do to take this to site is pull these off, unscrew these in the middle, put them all in the box, and then I can reassemble that in about 5 minutes. Filling valve. We connect on here. Once that's all set up on site, we run all our pipe work. When that's all fitted, then connect a hose onto there, and then we fill this thing up with water. Pressure gauge will come up. We normally fill it to probably about 400 kPa, 4 bar above atmosphere. It just means that then if there's a puncture, water will leak out, the pressure will drop very quickly, and we can see that there's a problem. We bleed the air out using this, then we shut it off and seal it, and we leave it there. I'll probably wrap it in plastic so it doesn't get covered in concrete when the guys are pouring the slab. Other than that, we're done. Here's the finished manifold installed on site. If you have any questions, leave a comment or send us an email. Thanks for watching.